bunkers. I spelled it wrong. That's how you spell it. That's nice. What the fuck is a Terra nuke?
This is not normal.
Yeah.
But who wants to be normal?
Who wants to be normal? Everyone does.
When you can be part of something special.
The body scanner reveals the brutal truth about
Good
your body
one,
that your
buddy.
regular
Hello
scale will
there.
never
Welcome
tell
to
you.
life.
For weeks, my scale showed I wasn't losing weight despite diet and exercise. I was about
Good one.
In the 1960s, the US planned to nuke Israel with hundreds of thermonuclear bombs, and Panama, and Alaska, all in the name
Why?
of progress driven by a mad scientist
Why?
to use the most destructive of weapons to build things, excavate canals, carve out harbors, tap oil and gas. This was Project Plowshare. It kept the US busy for 2 decades, burned hundreds of millions of dollars, and exploded dozens of nukes for a bright future. In the most feverish years of the Cold War, when the world got terrifyingly close to blowing itself up, nukes for peace. Our story begins with the brilliant Hungarian physicist Edward Teller, one of the key scientists of the Manhattan Project, the colossal effort that led to the first nuclear bomb.
Hello.
But almost from the
Hi.
beginning, he dreamt of destroying the world much harder. Traditional nukes, like the Hiroshima and Nagasaki ones, release energy by splitting
I'm just
heavy
watching
atoms like
videos, to be
uranium.
honest.
But these are rare, expensive, and the resulting bombs are difficult to scale up. So, Teller lobbied for a different approach: unleash the nuclear fire by smashing together hydrogen atoms. That would allow for bombs thousands of times more powerful. The problem was technically hard, but in the 1950s, Teller solved it. The terrifying new thermonuclear bomb made Hiroshima and Nagasaki look like firecrackers. Nuclear fire strong enough to end human civilization itself. The Soviet Union followed quickly, and the new madness for destruction took over the world.
Hello, new
Teller was
people.
having the time of his life as he got to chase his nucleus dreams like a bomb so powerful that it would wipe out civilization in one single strike. A real thing the US actually started working on. We've told this story before if you want to watch it.
I did not realize.
As the perfectly sane man he was, Teller had other great ideas, like nuking the moon to show the commies who's boss. And if H-bombs could destroy the planet, maybe they could also reshape it. The logic wasn't entirely obvious. Humans have been using explosives for mining and engineering for centuries.
I'm just watching videos.
H-bombs offered the same service with much more enthusiasm at a decent cost. Why not use them to dig ditches and make holes at a planetary scale? The idea of nukes for peace was also pretty convenient. With public opinion increasingly opposed to the arms race and ever more terrified by World War III, nuclear engineering was a way to keep on testing nuclear weapons without saying you were testing nuclear weapons. So, in 1957, the US launched Project Plowshare, a bold plan to use nuclear explosions for peaceful engineering. And who would be put at the head?
We love this.
Cutting through continents. In 1956, Egypt had just nationalized the Suez Canal, a vital artery for global trade and oil delivery to Europe. So, one of the first ideas of the new Build with Nukes doctrine was to blast open a new one through the Israeli desert.
Yeah, problem with that, radiation poisoning. That's gonna kill a lot of people. So let's not do that. Let's not.
Other side of the world, the Panama Canal had long been in need of an upgrade. Scientists explored extension routes and found they would need to remove 1.2 billion cubic meters of earth, 500 Great Pyramids of Giza. A monumental task that would cost $6 billion if done with shovels, but only $3.1 billion with nukes. Time to blast open a...
Do you see that number?
Shovels, but only 3.
You know how much more money that is compared to that? Nukes. Nukes. Costs more money for manpower and shovels than it is for nukes. That's crazy. Wow.
1 billion with nukes. Time to blast open a panatomic canal. But even Teller understood that before nuking through continents,
Ow.
you should start small.
That
So the
hurt.
first miracle of Project Plowshare would be a new harbor in Alaska. In just a few glorious milliseconds, 5 nukes with the combined punch of 170 Hiroshima bombs would carve out a 500 by 200 meter trench, opening the region to commerce and prosperity.
Yeah.
Local
Yeah,
communities
it totally
were
makes
thrilled with
sense.
the idea, but Teller insisted that the
Hello,
dangers of
it's a
nuke
node.
engineering had been greatly exaggerated. The major concern was
Hey,
radioactive
hello everyone.
contamination.
Welcome to live.
Canals and harbors were great, but nobody wanted them glowing with radioactivity for thousands of years.
Yeah, nobody
Luckily,
does.
Teller had a plan: nuking the land from below. In a nutshell, nuclear excavation
How do you nuke the land from below? I mean, you. Oh wait, no, wait. That's confusing.
works like this. You drill a hole a few hundred meters deep and place the bomb at the bottom. When it goes off, the blast hollows out a cavern in the rock and flash melts its walls into magma. The molten rock pools at the bottom, the ceiling collapses, and the collapse ripples upwards until it reaches the
That's
floor,
cool.
where it forms a crater. The result is a massive hole on top, with the radioactive debris sealed under hundreds of thousands of tons of rock.
That makes so much sense.
You can ask me anything.
I don't like these ads.
Where did we come from?
Where did we come from? A bee and a
With the
bird.
theory looking flawless on paper, the time had come to actually test it. But before the government bombs anything, let's get some propaganda protection, just in case. Our partner Ground News is a website
No.
planning to lift its banners, warn of one side of the norm easier than others. The fiasco begins.
Ooh.
Plowshare debuted in 1961 in the desert of New Mexico. A nuke with the power of 3,100 tons of TNT was buried 360 meters deep in the heart of a salt deposit. The goal was to explore a new idea to generate electricity. The explosion would melt the deposit into a pond of red-hot liquid salt whose heat could be pumped up to power turbines. A hybrid of fusion and geothermal power brought to you by H-bombs.
Yeah,
Above
hydrogen
ground, hundreds
bombs.
of officials,
That's what
scientists, and
H-bombs are.
international guests had gathered to witness the birth of a new era. Everyone held their breath as the countdown ticked.
Nuke it, nuke it.
With a distant thud, the ground shuddered. Deep below, the explosion hollowed a cavern the size of over 10 Olympic swimming pools. But Teller's team had missed a tiny detail. The salt contained far more water than expected,
Dummy.
which turned into superheated steam that massively amplified
Yeah.
the blast.
Then it blew it
The hole
up.
used to
Then
lower
blew
the bomb
the
had been designed to
shit
collapse
up.
and seal itself
Or
after the
whatever.
explosion, but the unexpectedly monstrous pressure broke through. So,
Aww.
a few minutes after the blast, a plume of radioactive steam erupted from the shaft, damaging
Dang.
cameras and instruments and bathing everyone in a strangely itchy sauna. The US government tried their best to convince everyone that things hadn't been that bad, but for some reason, the masses had a problem with clouds of radioactive fallout, even from peaceful nukes. But that wouldn't discourage Teller. So, to show the world how cool H-bombs could really
cool
be,
H-bomb.
he scheduled another test, one 30 times more peaceful.
I gotta turn this off real quick. What is that face, my guy? What is this? What is that? You know what? No, I'm taking a picture of that. That's actually pretty funny.
In July 1962, while Cuban officials were visiting Moscow to negotiate a missile deal that would almost spark World War III 3 months later, a thermonuclear bomb worth 7 Hiroshima nukes exploded 200 meters underground in the Nevada desert. This time, the goal was to test nuclear excavation itself and check how big the crater could get. The blast displaced 12 million tons of soil and hollowed
I did not pause it.
out a gargantuan crater 100 meters deep and 400 meters across, the largest artificial crater in US history. But digging with nukes is tricky. Bury the bomb too deep and you'll only get a disappointing dent. Bury it too shallow and you risk launching a radioactive cloud into the sky, which was exactly what happened. Someone had miscalculated the depth of the explosion,
Dumbass.
and a plume of
How do you miscalculate this? Oh,
radioactivity punched through. Fallout was detected as far as South Dakota and Illinois, and panic broke out
yeah,
in
that's
Utah
sort of the
when radioactive
calculator's fault that
iodine was found
happened.
in milk. It turned into one of the dirtiest tests on US soil ever. Just one more nuke, bro. For years,
Bro. Gang, I did not.
peaceful fallout. Meanwhile, Teller's proposals got weirder. Liquefied tar sands in
Hello.
with nukes. Blast a highway through the Sierra Nevada
Hi, fly.
with nukes. Connect rivers in Mississippi with
I
nukes.
fly.
But the crown jewel of nuclear dreams was still the Panatomic Canal.
Night.
A legion
Good
of
night.
scientists worked on it, and plans got disturbed.
I'm good.
One of the
Just
top
bored.
contenders was Route 70,
I'm watching Kurt's
an
Gazette.
80-kilometer
Kurt's
trench across
Gazette.
pristine Panamanian jungle that was short,
How are
flat,
you?
pretty empty, and perfectly nukeable. 250 bombs with the power of 8,000 Hiroshimas would do the job.
8,000 Hiroshimas. 8,000 to blow up that portion of the Panama Canal. Do you know how crazy that is? Just one of those killed over 45,000 people instantly on Hiroshima. It was 45 to 65,000 people died just from one of those. Instantly.
$43,000 people across 17,000 square kilometers would still have to be evacuated.
Yeah, evacuated. You know how much radiation buildup that is? For 8,000 bombs that was dropped on Hiroshima? Insane! All that radiation buildup would not just affect this portion. Will not just affect this portion. It would also go out through here too. Colombia. Ow. Go through a bit of Colombia. Go all the way over here too. And possibly up here as well. So you're having miles and miles of radiation, if not calculated properly, underground. Oh, and counting the water too. Because radiation can also pollute the water. So you're having all this over here polluted like hell. All this just completely devastated by radiation, including the Caribbean too.
You know, just in case. And shockwaves might shatter windows as far as Costa Rica and
See?
Colombia. But what were such details in the grand scheme of progress? So let's rewind history and press the button to see what might have happened if Teller had got his way. Ready to push the button? 3, 2, 1. Boom. The first round of nuclear salvos close to both coasts obliterates hundreds of square kilometers of pristine rainforest in seconds. A roaring success. Unfortunately, a cloud of fallout catches the Pacific winds. Weeks later, spikes of radiation are found over beryllium and radioactive iodine, cesium, and strontium.
Like I
start to enter the
just
food
said.
chains of both oceans.
Like I just
Tuna and
said.
sharks become radioactive. One option would be to stop, but to have a radioactive scar across the jungle, contamination of 2 oceans, and no canal, better push through. So a second round of blasts goes off in the central Chucunaki River Valley, only to find that the central part of the isthmus had far more clay than expected. As soon as the rainy season hits, landslides clog the new craters like a self-healing wound. The choices: leave a mud-choked glowing vista through the rainforest, or begin a colossal engineering nightmare just to keep the jungle from landsliding onto the canal. Not to mention the ecological apocalypse and the devastating PR victory that 120 megatons of nuclear peace over Latin America would give Cuba and the USSR. Luckily, in our timeline, the US blinked and began to sober up.
1 in 4 taxpayers was a victim
Brother.
of identity theft.
We're not just taxpaying Americans.
I do not care.
In 1970, a final report killed the Panatomic Canal, and with it, all nuclear excavation projects. But Teller wasn't ready to let go, so he turned to nuclear fracking. Not because it made sense, but to keep Plowshare alive. Just one more nuke, and I'll build the future, bro. But several explosions later, the result was ultra expensive.
Yeah. If that were actually, I'll go back just a bit. Just to show the diagram of the... Where was it? Right here. Hold up. I'm gonna show the diagram real quick. Yeah, this. Shockwaves. Over 8,000 nuclear bombs dropped on Hiroshima. Crazy. And that combined force would annihilate anything in this general area from around this part. Things would still get blasted off here too. In this zone too. And that, not as much damage, but still would cause enough with the amount of combined force from 8,000 nuclear bombs. Not to mention radiation fallout in here, like I just said, up in here too. It also do fallout over here, and lots of parts over here.
As far as Costa Rica and Colombia. But what were such details? Stop. Healing wound.
Here, hold up. I'm gonna go back to the
report
point we were.
killed the Panatomic Canal. Just what was ultra expensive,
There we go.
radioactive gas impossible to sell. In 1977, after 20 years and dozens of nukes across the US, Project Plowshare was finally cancelled without reaching any of its goals. No canal, harbour or tunnel had been built. In hindsight, it's easy to see how insane the idea was. But at a time when World War III felt imminent, when kids were playing with atomic toys as mushroom clouds filled the sky, using nukes to build a better future probably did feel like a great idea. On our new channel Night Shift, we're telling dark and novel stories from history that you might
Ooh.
never have heard before. And that
Night
might
Shift. That's your new channel. That's cool. Huh. Well, that's the end of that video. That was 10 years ago. I don't want to watch things 10 years ago. Super Voids. I love this type of stuff.
Customize and save hundreds with Liberty Mutual. Maybe where's the golf cart?
You ate it.
The vast majority of the cosmos is voids. Gigantic, unfathomably large spaces of empty nothingness. Bubbles of eternal night stretching hundreds of millions of light years, almost entirely devoid of galaxies, stars, or light. The loneliest places in existence. Voids are not just the absence of stuff, but weird worlds of darkness that are growing, drifting, colliding, and merging with each other. Inside them, space itself is stretched violently, and it's almost impossible to enter them. Simply
Oopsies.
put, voids are weird
Oopsies.
and scary.
Can I
But they
flip the
sculpt
screen?
entire universe and may ultimately decide its fate. Today, we know of over
Okay.
8,000 voids and supervoids, and we keep discovering more. No matter how large a cluster or supercluster of galaxies gets, there always seems to be an even larger void nearby. Let's jump off the cosmic cliff and drop into the heart of cosmic nothingness. The loneliest place in the universe. You're zooming away from Earth at thousands of times the speed of light, leaving our solar system and our solar neighborhood behind. Now we see the entire Milky Way with its 200 billion stars and dozens of dwarf galaxies zipping around it. 2.5 million light years away on a collision course is giant Andromeda and its own swarm of satellite galaxies. we're now moving 1,000,000 times faster than the speed of light, seeing the local group of over 50 galaxies woven together by gravity, rivers of gas, and invisible scaffolds of dark matter. This is our pocket of the universe, 10 million light years across. No human will ever leave it, except for you, apparently. As we zoom away even faster, we see the Virgo supercluster, a colossal wall of more than 2,000 galaxies spread over roughly 100 million light years. Careful now, you're right on the edge of the cosmic cliff where the true deep darkness begins. The local void, a gigantic empty bubble 200 million light years across. If it was a bright thing and not absolute darkness, it would fill 40% of the night sky we see from Earth. All around us are dozens of such superclusters and gigantic voids filled with suffocating emptiness. You're now traveling towards the greatest and emptiest nothing in existence, right into the center of the Boötes supervoid, a cosmic desert around 300 million light years wide. So gigantic it should contain thousands of galaxies. But instead, what do you see?
Nothing.
You're surrounded by perfect darkness, the most absolute blackness the human mind can conceive. There is no up or down, no motion, nothing to orient yourself. There's not a single sign that the outside universe even exists. It's an inescapable prison, and this isn't some exotic corner of the cosmos. This is how the vast majority of the universe feels to human eyes. Just silent blackness without any movement. Everywhere, forever. Although there is something mysterious hiding in the dark, faint tendrils of dark matter, penetrating into the void like cosmic lichen. A miniature echo of the much larger forest of dark matter filaments that forms the scaffold of galaxies and galaxy clusters outside the void. And at their tips, we find faint bluish specks in the ocean of darkness. Void galaxies, lonely fireflies, unable to light up the night. The rarest galaxies we know, very isolated, very lonely. A universe of bubbles. Before we could look deep into space, astronomers thought we lived in a uniform cosmos with galaxies spread out evenly. But instead, we found that galaxies, cosmic gas, and dark matter were arranged into a vast cosmic web. A recurring pattern of sheets and filaments organized around enormous empty gaps, meeting at dense knots with galaxy clusters and superclusters. But this structure is not static. It just seems to be because the distances between galaxies are so incredibly vast. In reality, galaxies shoot through space at speeds of millions of kilometers per hour. They're on collision courses, orbiting each other, moving towards the center of larger galaxy clusters millions of light years away. But they always seem to stick to the rims of voids like reflections of light on soap bubbles, which is kind of weird. If they're this dynamic, shouldn't a galaxy shoot into a void occasionally? Well, voids are actually extremely hard to enter for galaxies from the outside, at least naturally, because gravity becomes weird at their edges and even weirder deeper inside them. If you didn't know better, you might think voids spit out anything trying to get inside, pushing galaxies to the edge. The way gravity works is that everything with mass in the universe attracts every other thing with mass. And since there's almost no mass inside, the cosmic web of galaxy superclusters on their edges are pulling things out of voids. The emptier a void is, the harder gravity is pulling on what remains. It's really like a tug of war where one side isn't even trying. Over time, voids are really only getting even emptier, and the walls and knots around them denser and brighter. Would it be hard to fly into a cosmic void with a spaceship? Well, not technically. The hardest part is escaping the gravity of your home galaxy. It also doesn't make much sense because what exactly do you want to visit inside a void? It makes sense to fly into a void if you want to hide, like really, really hide. But what cosmic horror would be scary enough for a civilization to try to escape into a cosmic void? Galaxies in the crowded cluster regions like our Milky Way are very active. Since its neighbor's gravity tugs and pulls at it, they collide and merge. Void galaxies are so isolated, that they're aging in slow motion. They tend to be smaller, bluer, and full of gas, birthing new stars slower and calmer. So void galaxies could be the last places that will stay habitable in our dying universe. The last star in the universe will likely be born here. So maybe in 100 trillion years or so, a desperate alien race will embark on an impossible journey to stretch their existence just a bit longer inside a void galaxy.
What if you could clean your retainer?
No,
No
I
more brushing
don't
or tablets. Over 4
care.
years ago, our team of engineers knew
I
that
don't care.
There's one more thing that makes voids unique places: dark energy. The mysterious force that most scientists think is accelerating the expansion of the universe and will ultimately cause its demise. We can't see dark energy do anything inside our galaxy or inside clusters because there's too much stuff putting things together via gravity, but we can see its effects inside voids. Here, dark energy blows up the bubbles of nothing. This is where the acceleration of cosmic expansion becomes visible. As voids are getting larger and larger, they're breaking the structure of the universe. The beautiful galaxy filaments are slowly being ripped apart. As the emptiness encroaches, walls of thousands of galaxies are thinned out and pulled towards the edges, attracted by much denser regions of the margins, giving space to the emptiness of two void bubbles becoming one. In the far, far future, supervoids will take over the observable universe, crushing clusters and expanding further
I know
and
lots
further
about
until the
astronomy.
entire observable
I
universe
know lots
is nothing
about it.
more than a gigantic void.
I didn't
of
know this
nothingness,
though.
the loneliest place in existence.
I mean, I knew about voids and super voids, but I didn't know what
Let's
they
head
did.
back to Earth. When we land, please exit through the gift shop and pick up a few souvenirs. We created
Yeah,
this.
guys, get their stuff. Get their stuff, guys. It's so perfect. Anyways. Yeah, could the Big Bang happen again? Maybe.
Okay, I have something important to tell you. Right now, the universe is expanding, and that expansion is getting faster.
No, I didn't know that.
For 25 years, physicists thought this acceleration would just never stop, that the universe would expand forever until every star burns out, every black hole evaporates, and all that is left is cold, empty.
It's gonna
and
take
nothing.
non-millions of years for black
Of
holes to burn out.
But just last year, this telescope in Arizona mapped 14 million galaxies and found
Or
something nobody
decillions.
expected. Of course, pulling the universe apart appears to be getting weaker, and if it keeps fading, gravity eventually wins. The universe
whoa.
stops expanding, reverses, and collapses back in on itself, crushing every galaxy, every star, every atom in your body into a space smaller than a proton, the Big Crunch. But something else genuinely kept me up at night when I was researching for this video. Some physicists think the story doesn't stop there. They think the crunch triggers a
Oh, I know what this is. I know what this is. It's like infinite regression. You have a universe. The point right here. That's where the big crunch happens. So what that theory is it collapses so far, so fast on itself, it creates infinite energy. It also collapses on itself so far to the point where it's nothing, but fast enough to the point where it has infinite energy, which is what black holes have, a singularity. So the singularity will expand. Well, technically not expand, but it'll more or less shatter, and all that energy from inside this point will expand out into a universe.
brand new Big Bang, a new universe born from the death of ours, the Big Bounce. So in this video, we're going on a journey to the end of time to see how the death of our universe could actually result in the birth of another.
Yeah, thing about that though, it doesn't make sense. Just so you know, nothing about this makes sense. I already did my stuff on this. does not make sense.
Imagine being able to build anything just by thinking
The
about
Big
it.
Crunch
Meet
doesn't
Base
make
44,
sense,
a
and the
complete
Big
AI
Bounce
creation.
doesn't make sense.
13.8 billion years ago, everything in our universe was much closer together. And I mean everything. Not just the galaxies and stars, but the space that those galaxies exist within was squished together tightly. And
There were no galaxies at the time. Also, why did I pause it like that?
then
It's really it's the yeah, that's what I'm watching. Technically, yeah. I mean, if the force that keeps pulling it apart gets weaker, and gravity collapses on itself really fast to the point where it creates a singularity, and that singularity has infinite energy to the point where it creates another universe, then yeah, it can happen. But like, that would just go into infinite regression, which none of that makes sense.
expanded. If it started out at the size of a marble, it grew to the size of the observable universe in less than a trillionth of a trillionth of a trillionth of a second. The classic idea of a Big Bang.
Now let's search up a trillionth of a trillionth of a trillionth of a second. A trill. Trade. So just so you know, that's how fast it expanded. 10 to the power of -3. Now it's that converted into an actual. Okay, 10 to the power of -36 converted into numerical numbers. Now, that's how much time it took for the universe to expand in a trillionth of a trillionth of a trillionth of a second. One undecillionth of a second. That's crazy fast. Crazy. Wait, can I go in here and it's so small of a fraction that it basically happened instantly. That's how fast it formed.
Singularity was popular for a long time, but recently scientists have started to favor an alternate theory, cosmic inflation. I have a full video all about this that you should watch after this one, but for now, all you need to know is the universe was squished together really tightly, and for some reason we still don't quite understand, expanded into the massive universe we can see today. In the early
Doesn't make
1900s,
sense.
physicists figured out that the universe was expanding, so they immediately started thinking far into the future, billions and billions of years, to try and figure out how the universe might end. And there was one idea that stood above the rest because the logic was simple. If there was enough stuff in the cosmos, then gravity will eventually win. As the universe expands, it will slow down as gravity starts
Wait.
to take over. One
No.
day it stops and
No. No.
reverses. Think of it like throwing a ball straight up into the air. You throw it, it
Go ahead.
rises, and then it falls back down to the earth thanks to gravity. Well, the universe could do basically the same thing, expanding outwards and then
Here's my problem with that theory. So, with the theory itself, it just says that, like, what does it say? So for the Big Bang Theory about all this stuff, the singularity had infinite energy. Our universe does not have enough output
collapse.
energy to even get close to infinity. Hold up. Oh my god, I cannot type on this. Yeah, it's reverse. I mean, the theory itself doesn't make sense. Because you can't have infinite regression. I mean, science sort of supports it, but it doesn't make sense. It just does not make sense. No, I'm not gonna listen to lies. Well, it's not really lies. It's not lies. Yeah. Oh. I didn't even realize I clicked that. No, I love it in the end of the same time. I hope you know that does not tell you your intelligence. Just because you answered 10 questions does not mean your IQ is 150. It takes so much more to actually get that, to actually get your IQ than this.
Well, I basically bought this roof over the internet, which wasn't something I'd ever done
Yeah,
before.
no, you didn't. I don't even know what I clicked either. That's the thing. Anyways, I would lie for a bit. Time dilation. Huh. Oops. Why mission? course, this is the state I live
What
in.
if I told you there's a single lake system holding enough fresh water to submerge the entire contiguous United States under 10 feet of water? Or that despite being hundreds of miles from the nearest ocean, it hides a massive underwater graveyard of over 6,000 shipwrecks. Welcome to
Yeah.
the North American Great Lakes, a region often thought of as just a cluster of big lakes, but one that is actually a massive, slow-motion waterfall with an economy large enough to rival the world's biggest countries. Here are 15 incredible geography facts you never knew about the Great Lakes region.
I've lived here all my life. I wonder what I don't know about
When
it.
we look at a map, it's easy to underestimate the sheer volume of the Great Lakes. Together, they hold an incomprehensible 6 quadrillion gallons of water.
Yep.
Put that in perspective. This represents roughly 21% of the entire planet's surface fresh water,
Yeah, 21%.
and a staggering 84% of North America's supply.
84.
If you were to somehow pull the plug and pour all of the water over the contiguous United States, the entire country from coast to coast would be submerged nearly 10 feet underwater. This
Mhm.
massive volume makes the region one of the most strategically and ecologically vital areas on Earth, serving as a
Yeah.
global freshwater bank that dwarfs almost every other lake system.
And this
trailing
place
only
is
behind
not
Russia's
talked about a
ancient Lake
lot.
Baikal, the planet's polar ice caps, in terms of total freshwater volume.
Yeah.
Lake Superior more than lives up to its name. It's an absolute giant. By surface area, it's the largest freshwater lake on the entire planet, covering over 31,000 square miles, an area roughly the size of Austria, but its surface only tells
The size of Austria.
half the story. Because it reaches depths of over 1,300 feet, Superior holds over half of all the water in the entire Great Lakes system combined. The volume is so immense that you could pour all the water from Lakes Michigan, Huron, Erie, and Ontario into Superior's basin. Throw in the volume of 3 additional Lake Eries, just for good measure, and it still wouldn't overflow.
Uh-huh.
Deep, notoriously frigid waters create a formidable and rugged aquatic environment that behaves much more like a turbulent inland sea than a traditional lake. The Great Lakes are so vast that they act as localized weather engines, significantly altering the climate of the surrounding land. Because water retains heat far longer
This is also one of the hardest places on Earth to be an astrologist. Because of all the lakes surrounding Michigan, it's the hardest thing to be here. Because you never know what the weather's going to be.
than soil or rock, the lakes stay relatively warm deep into the autumn and early winter. When freezing, dry Arctic air sweeps down from Canada and passes over these massive bodies of relatively warm water. It rapidly evaporates moisture into the atmosphere. This moisture quickly condenses and is dumped onto the downwind shores, the lee sides, as intense, localized precipitation known as lake effect snow. This phenomenon creates specific snow belts where cities like Buffalo, New York, and Grand Rapids, Michigan can suddenly receive multiple feet of snow in narrow bands, while towns just a few miles away might see nothing but clear, cold skies. It's helpful to think of the entire Great Lakes system not as 5 stagnant pools, but as one massive, slow-moving river flowing west to east toward the Atlantic Ocean. The journey begins in Lake Superior, which sits at an elevation of about 600 feet above sea level. From there, the water flows steadily downhill through the St. Mary's River into Huron and Michigan, then down through the St. Clair River system into Lake Erie. The most dramatic step in this continental staircase occurs between Lake Erie and Lake Ontario. Here, the water plunges over the Niagara Escarpment, dropping 326 feet in elevation. This sudden, violent bottleneck is what creates the world-famous Niagara Falls, before the water finally continues its descent through the St. Lawrence River to the sea.
1 in 4 taxpayers was a victim of identity theft.
We're not just tax-paying Americans.
We're fraud paying.
While the lakes feel permanent
fuck?
and ancient, they are incredibly young in the grand timeline of geologic history. The Great Lakes as we know them today took their current shape only about 10,000 years ago. At the end,
Oh, did they? then why is there a rock over where a waterfall I went that was older than the dinosaurs? Can you tell me that? Tell me that. I found a rock older than the fucking dinosaurs combined. And you're telling me the Great Lakes formed over 1,000 years ago? I call that bullcrap. A rock over here is older than the dinosaurs.
Of the last ice age. Prior to this, the region was flattened beneath the Laurentide ice sheet, a massive glacier up to 2 miles thick. As the climate warmed, this gargantuan ice sheet retreated northward, acting like a continental bulldozer. The moving ice gouged deep, massive basins into the Earth's crust, exploiting softer rock layers while leaving harder rock behind. When the ice finally melted, unimaginable volumes of glacial meltwater filled those newly carved basins, creating the magnificent freshwater seas that now dominate the North American map. Let's take a quick break. There's a reason rivers don't flow backward and borders don't move for fun. Just like there's a reason why Morgan & Morgan is America's largest injury law firm. When you're dealing with something important, whether it's your lunch or, much more seriously, a personal injury, who you put in charge of barricade some record with even fun. Being technically classified as lakes, these bodies of water are incredibly dangerous to navigate. Their sheer size allows storms to build rapidly, while their relatively shallow depths compared to oceans cause waves to become incredibly steep and close together, battering ships relentlessly. As a result, the Great Lakes are a massive underwater graveyard. Historians estimate that there are between 6,000 and 10,000 shipwrecks scattered across the lake beds, claiming the lives of an estimated 30,000 sailors over the centuries. The most infamous of these tragedies occurred during the Gales of November, a fierce weather pattern that famously sank the massive freighter.
Yes. I cannot say it.
Gales of November, a fierce weather pattern
Edmund Fitzgerald.
that famously sank the massive freighter SS Edmund Fitzgerald in Lake Superior in 1975. Reminding the modern world that even the
I
largest
actually went to
steel
the,
ships are at the mercy of the inland seas.
I actually went to the spot where it sank, and I found one of the spikes of it too. One of the frames of it that was built on the land, and I found a couple of planks too, which is really crazy.
The cultural geography of the region is deeply woven into the names of the lakes themselves, 4 of which derive directly from the languages of the indigenous peoples who have lived along their shores for millennia. Michigan is an adaptation of the Ojibwe word Michigami, which translates simply to Great Water. Ontario comes from the Wyandot word, believed to mean Lake of Shining Waters. Erie was named by early French explorers after the Eries tribe, an Iroquois group who lived along its southern shores. Huron is the exception, being a name given by the French to the local Wyandot people. Acknowledging these names is a constant reminder of the complex, rich First Nations and Native American history that predates European arrival by thousands of years. In the early 19th century, the formidable Appalachian Mountains acted as a massive geographic wall blocking the movement of goods and people between the Atlantic coast and the resource-rich interior of North America. This all changed in 1825 with the completion of the Erie Canal. This monumental engineering feat artificially connected the Hudson River Valley in New York directly to Lake Erie. Almost overnight, transport costs for bulk goods plummeted by 95%. The canal funneled the immense agricultural wealth of the Midwest straight into New York, bypassing the alternative route down the Mississippi River. This geographic pivot fueled a massive population boom in the Great Lakes Basin and cemented New York City's status as the financial and commercial capital of the United States. As Chicago rapidly industrialized in the late 19th century, it faced a massive geographic and public health crisis. The city's sewage was flowing directly into the Chicago River, which emptied into Lake Michigan, the exact same place the city drew its drinking water. This deadly loop caused devastating outbreaks of waterborne diseases like cholera and typhoid. To save its population, engineers executed one of the most audacious infrastructure projects in history. They reversed the flow of the Chicago River. Completed in 1900, a massive canal system was cut through the subcontinental divide. By artificially lowering the river's channel, the water was forced to flow backwards, sending Chicago's wastewater south towards the Mississippi River Basin, permanently altering the hydrology of the region to protect its freshwater source.
Mm-hmm.
You know, a lot of people think that in order to conceal carry, you're going to need a tactical belt and a set of jeans. Well, I'm here to
Good
tell you,
one, buddy.
It's strange to think of naval warfare taking place in the middle of a continent, but during the War of 1812, the Great Lakes were a fiercely contested war zone. Both the United States and the British Empire recognized that controlling these waters meant controlling the vital supply lines to the North American interior. This led to intense arm races and shipbuilding campaigns on the shores of Lake Ontario and Lake Erie. The conflict peaked at the Battle of Lake Erie in 1813, where American forces under Oliver Hazard Perry decisively defeated the British fleet. The stalemate of the broader war ultimately led to the Rush-Bagot Treaty of 1817, which strictly limited military vessels on the lakes and established the foundation for the famously demilitarized US-Canada border. Today, the Great Lakes region is far more than a geographic feature. It's an economic titan. The area forms a massive cross-border megalopolis stretching from Chicago and Milwaukee in the west, through Detroit and Cleveland, all the way to Toronto and Montreal in the east. Roughly 60 million people, almost a fifth of the US population and a quarter of Canada's, call this basin home. Because of its dense population, historic manufacturing infrastructure, and vast agricultural output, the region is a global powerhouse. If the Great Lakes region were an independent country, its highly integrated binational economy would generate a GDP of over $6 trillion US.
6 trillion. And that's for one state.
Making it the third or fourth largest economy in the world, heavily driving the North American supply chain. To move heavy cargo from the mines of the upper Midwest to the steel mills of the lower lakes, massive freighters must navigate the St. Mary's River, which connects Lake Superior to Lake Huron. However, the river features a treacherous 21-foot drop over a series of violent rapids. The solution is the Soo Locks, located in Sault Ste. Marie, Michigan. These engineering marvels are the busiest lock system in the world based on the tonnage of cargo that passes through them. Handling around 10,000 vessel passages a year, the locks lift and lower massive ships carrying 86 million tons of cargo, primarily iron ore, coal, and grain. This single geographic choke point is so critical that any prolonged shutdown would send shockwaves through the entire North American manufacturing economy. Beyond global trade and heavy industry, the most critical function of the Great Lakes today is sustaining human life. They act as the primary drinking fountain for more than 30 million people in the United States and Canada. This staggering reliance makes water quality management one of the most pressing human geography issues of the 21st century. The lakes face constant modern threats, agricultural runoff causing toxic algae blooms,
Probably after this
particularly
video,
in
my
the shallow
in the
warm waters
live.
of Lake Erie, legacy industrial pollution, and invasive species like zebra mussels that disrupt the food web. Protecting this watershed requires constant, complex international cooperation between 2 federal governments, 8 U.S. states, 2 Canadian provinces, and numerous tribal nations. While usually associated with vast open horizons, the Great Lakes also boast a surprisingly complex island geography. There are over 35,000 islands scattered throughout the system, creating unique, isolated ecosystems and isolated human communities. The crown jewel of this island system is Manitoulin Island, located in the Canadian waters of Lake Huron. Not only is it the largest freshwater island in the world, large enough to support a permanent population of around 13,000 people, but its geography gets even more bizarre. Manitoulin is so large that it contains over 100 of its own lakes. Fascinatingly, some of those lakes are large enough to contain their own islands, creating mind-bending geographical anomalies of islands on lakes on an island in a lake.
Yeah. Yeah.
The
That's
Great Lakes
where I
aren't just an
live.
internal transport
Is-
network.
oh, that's
They're
not where I
connected
live.
directly to the global economy via the Great Lakes St. Lawrence Seaway.
That's the state I
Completed in the
live in.
1950s, this massive system of locks, canals, and dredged channels allows deep draft ocean-going
No one
vessels, often
realizes-
called salties, from all over the globe to sail straight into the heart of the North American continent.
No one
Because
realizes
of this
just how
artificial
important the
geographic
state is.
connection, a ship can load a cargo of grain at the port in Duluth, Minnesota, which holds the title of being the furthest inland freshwater port in the world, and sail continuously for over 2,300 miles, bypassing waterfalls and rapids until it reaches the Atlantic Ocean and heads off to international markets. There's not another single geographic feature more prominent or more important to the United States and Canada as the Great Lakes. They are, for lack of a better term, the continent's savings account when it comes to fresh water. And because of that, they've developed as one of the most important cultural and economically powerful regions in the world. This week, I'm climbing a volcano in Guatemala that's actively erupting to find out one thing. Why are Central America's volcanoes so active and the Pacific Northwest so quiet? So come join me over on my travel channel.
What do you think? What's in the West? Yellowstone. Yellowstone is the biggest underground volcano in the world. If it blew up, well, the reason why it's so active is because Yellowstone is becoming active. That's why the western volcanoes are always so active, is because of Yellowstone. Oh, I'm gonna end the live here, guys. Well, have a good one. Sleep well tonight. Hope you have a good day tomorrow. I hope you guys had a good day today. And bye now. Bye bye.